Chemistry of Alkynes. In this chapter, we will learn how to name alkynes as per the IUPAC nomenclature. We will examine the structure of alkynes and learn how it influences its reactivity. We will explain the acidity of terminal alkynes based on the electronegativity of sp carbons. We will study the mechanism of electrophilic addition reactions in alkynes and explain regioselectivity of products. We will explore the use of acetylide anions and alkyl acetylide anions as synthons in organic synthesis. Alkynes nomenclature. Alkynes are unsaturated hydrocarbons containing one or more carbon-carbon triple bond. In IUPAC nomenclature, alkynes are named by replacing the ending "ane" in the alkane with the ending "yne". Thus, the first two members of the alkyne family of compounds are called ethane and propyne respectively. IUPAC allows the older name acetylene to be used for ethane. In higher chain alkynes, the position of the triple bond is indicated by a number. The name 1-butane indicates that the molecule has 4 carbons and the triple bond is between carbon 1 and 2. 2-pentane indicates that the molecule has 5 carbons and the triple bond is between carbon 2 and carbon 3. In the common nomenclature, the names of alkynes are derived from acetylene. Thus, propyne, 1-butane, and 2-pentanes are referred to as methylacetylene, ethylacetylene, and ethylmethylacetylene, respectively. Alkynes nomenclature. If an alkyne contains a substituent, the triple bond gets the precedence in numbering. For example, in 4-methyl-2-pentane, the triple bond gets the number 2 and the methyl number 4. If the triple bond gets the same number, counting from either direction, then the substituents would determine the numbering direction. The substituents will get the lowest number and will be cited in alphabetical order. For example, in 1-chloro-5-methyl-3-hexane, the numbering is done from right to left to give the substituents the lowest numbers. One substituent group containing a triple bond is referred to by its common name, propargyl. Propargyl chloride is an example of a compound containing a propargyl group. Structure of alkynes. The first member of the alkyne family is ethane, common name acetylene. Acetylene and all alkynes contain a triple bond consisting of 1 sigma bond and 2 pi bonds. The bond dissociation energy for the triple bond is 196 kilocalories per mole. Each carbon in acetylene is in sp hybridization state and the molecule is linear. The electron density in the sigma bond lies in the internuclear area. The pi bonds wraps around the sigma bond, giving the molecule a cylindrical symmetry. Due to the presence of pi electrons, alkynes like alkenes behave like a nucleophile. Electrophils readily add across the alkyne triple bond in what are called electrophilic addition reactions. Relative acidities of ethane, ethylene, and acetylene. From the pKa values, it is clear that acetylene is more acidic than ethylene, which is more acidic than ethane. Relative acidities are strongly influenced by the hybridization state of the carbon to which the hydrogen is bonded to. A hydrogen attached to an sp carbon is more acidic than that is attached to an sp2 carbon, which in turn is more acidic than that is attached to an sp3 carbon. An sp carbon has a greater S character than an sp2 carbon, which in turn has a greater S character than an sp3 carbon. This results in the electrons on sp carbon being closer to the nucleus than one that is on an sp3 carbon. The greater S character of terminal alkynes, sp carbon, makes them more electronegative compared to sp2 carbon or sp3 carbon. It also makes the CH bond shorter. The anion resulting from the donation of a proton results in greater stability if the same is attached to an sp carbon due to its greater electronegativity. Acetylide anion is stable due to the greater electronegativity of sp carbon.